And hello. Hi, everyone. Thank you again for joining us for another session of JNation Online 2020. And here with us today, we have Philipp Krenn. Hey, Philipp, how's it going?
Good. How's it going for you?
I'm going fine. Thank you very much. So Philipp works for Elastic, and he's actually been with us for our JNation last year, right?
I was. Last year in Portugal. This year I'm based in Vienna, so this year coming to you from Vienna. But yeah, it is what it is.
It is what it is. I mean, we will enjoy you to be here with us again, but couldn't make that happen. So hopefully next year.
Absolutely.
Wonderful. Anyway, Philipp's gonna talk to us about containers for real integration testing, especially around the test containers, right?
Yes.
Wonderful. I'm really looking forward to see that presentation. Test container is one of my preferred leaves at these days, right? So without further delay, I'll hand it over to you. So please feel free to start whenever you want.
Thanks a lot. Yeah, and we'll kind of build up to test containers because I'm walking through various options basically, and we will conclude why you probably want to use test containers. By the way, I hope your catering is good. I just got a coffee for myself.
Oh, yeah, we were discussing that. We were discussing that on the Slack channels around. Usually we have like pork sandwiches, but today, I mean, probably people gonna have to Uber Eat, and let's see how that goes.
I hope your catering at home is good. You got a coffee, so let's dive in. So
yeah,
for the introduction already, I work for Elastic, the company behind Elasticsearch. I'm a developer advocate, so normally I travel around to show the good stuff that we have. Right now I'm not traveling, but I'm still trying to talk about the good stuff that we have. And this topic is not about logging what you might know as for a full text search. This is just testing, especially around data stores, integration testing around data stores, because obviously that is very close to our heart as well. So oftentimes you start writing your code and it might not be the best code, but it runs and works. And then as you progress in your developer career, you probably get into some other parts where you figure out that, well, maybe you want to do something else. Like maybe you want to have tests at some point rather than just having code that compiles, if you even use a compiling language. And then you progress to write unit tests. So I assume we're all agreed that you want to have tests. So you want to know how stuff is working or not working. And let's dive into the testing side, especially around data stores now. At first, you start with this like, okay, the unit tests work. This is great. So we're done, right? And then as you progress even further, you probably figure out that unit tests are not always kind of like the complete picture or everything that you can do. I have a couple of humorous examples where the unit tests kind of work, but the system as a whole is still not working. So on the integration layer, we are still having trouble. So here, for example, we have one where you can see, okay, you're not allowed to turn off the light switch because that also operates the elevator. And like the unit test for the light switch is probably working and the unit test for the elevator is working. But again, the combination is not doing what you would expect it to. This one is another famous example where people say like, well, the unit tests are working, but on the integration layer, this is probably not what you really want to have. Or maybe you have seen this one where the unit test for the right window works, the unit test for the left window works, but in the end, it's not really how your windows are supposed to work. Or maybe you know from a security point of view, this like, okay, this lock seems to do what you want, but it doesn't really. Or this one is the doors that keep each other busy. Like the unit test for one of the doors is totally fine. But again, the overall system is definitely not behaving the way you would want it to. Or this one here, where yeah, the individual pieces are working, and probably my favorite one is this one here. This is, I think, the best way to show that, okay, the unit tests work, but your system as a whole is probably dead, and that's not what you want. So I assume we agree by now that you want to have more than just unit tests. So you want to need to or move to that integration layer. And once you talk about integration tests, what often comes up are mocks. And I assume a lot of you are using mocks to some degree, like Mockito, EasyMock, JMock, whatever, and they totally have their place. But especially around data stores, we could argue that they also have not a specific place, or that they're limited in some things that they can or cannot do. So Nick Craver, he is working for Stack Overflow, and I really like his tweet thread, and I picked 2 tweets out of this one, where he was talking about mocking. He starts off with saying, well, you can mock a lot of things, right? And then, sure, but what are you testing in the end? In the end, you're not testing the actual system, but you are just running against the mock. He argues that, for example, if you try to test against a data store like Redis or any other data store, you really want to test it against Redis. You want to make sure that the socket works and that you can open the connection, and that the data type is actually there and supported and works as the way you want it to. And that if the server breaks in any way or changes something, you want to see that. So for example, if you work against version 1 and then you upgrade to version 2 with a breaking API change, if you don't update your mock, you will never see that something changed in the underlying system. And that's kind of the limitation, that a mock can tell you a lot of things, but it doesn't cover all the ground here, basically. So for some things, you need to spin up an actual server or service to test against that. So to make sure that everything works for that, this is where you need to go. This example here is, I'm not sure this translates to any other language, but in German, the original text here for Pippi Longstockings is this one here, which basically means I make the world the way I want it to. And I always say this is the same what you do with mocks, like you mock the world the way you want it to. So this is where you don't want to end up with that you create some mocks that are kind of decoupled from the reality. And this is also the main criticism here. Mocks definitely have their place, but not for everything. Or another example here is that you have the happy flow, that your user goes through a looping and avoids all the bad stuff, and then you walk over the mock data, basically avoiding all the pitfalls, and in the end, the mock is doing fine, whereas your actual user has been bitten or eaten alive or whatever by various of your bugs. So mocks don't cover all the ground. They are good if you need something that is fast, and also if you want to test against an external system that is not under your control, like some web service API, probably a mock is a good idea. Also because the other web service is probably not that happy if you run your tests continuously against them, creating load on their system, maybe even creating dummy data. If you run a service and somebody else does it against your API, you're probably not going to be super thrilled. But for data stores that you control yourself and that you can run yourself easily, probably you need to test or want to test at least some parts with the actual data store. So the next step, what many people have been doing or looked at, are the in-memory data stores. I always call them like the cousins of the actual data stores, something like H2, HSQLDB, Apache Derby, whatever you have. And the thing about them is that they are the same, but different, but kind of still the same. But when you have been long enough in the field, you will know that they always work until they don't. And the don't, that normally bites you when you want to bring something to production quickly, and then you haven't tested how dropping an index and then recreating the data works. Or it's always these little edge cases that the 99.5% or so of things work the same and work in your data store exactly as you would expect it between the in-memory database and the actual database, until it doesn't, where stuff falls apart again. So again, to have the actual confidence, you will probably need to test against the real data store at some point or to some degree. And since I work for Elastic with Elasticsearch, how does mocking or in-memory work for us? So the in-memory or embedded Elasticsearch initially was very easy because Elasticsearch is a Java process. So you could just include the dependency and run Elasticsearch embedded. And that was so successful that people started not doing that just for testing, but also for production. That was not really the idea, because then your process would run into out-of-memory exception. So it would be terminated violently, and then stuff would just break and you might lose data. And it's also very hard for us to test for all of these scenarios. So that's why, or one of the reasons why we stopped supporting embedded Elasticsearch, so that nobody would run that in production and then come to us afterwards to complain that something terrible happened to my data, and then you find out somebody ran it embedded, which really was not the idea here. Also, jar hell around dependencies, especially around stuff like logging libraries. That's a common thing where you run into dependency hell, or that Elasticsearch enforces the use of the Java Security Manager, and running in an embedded fashion, that is not really feasible. So long story short, Elasticsearch for quite a few years, like this is like almost 4 years ago since 5.0 came out, we do not support embedded Elasticsearch anymore. And while some projects have been building around that, and we'll look at one, this is probably still not where you want to go or want to be in the future. So the embedded world or in-memory world is often good enough. It's like the 99% case or so that covers a lot of ground. But sometimes you really want to test against the actual data store, or your data store does not support an in-memory variant, then you're out of luck anyway. So trying to test against the actual data store, how could that look like? You could just have a local installation of Elasticsearch. You could just run it in a Docker container. You could run it as a cloud instance, and then everybody tests against that cloud instance if you don't want to run that locally. I will pick a Docker container because it's probably easy to get the specific version that you want to run. You don't have to tell everybody, well, you have your local installations, now upgrade to this other installation. You just specify maybe in a Docker Compose what the setup should be, and then you can just test against that. So this is exactly what I want to look at. And we'll run through a couple of code samples. So just to give you a quick overview of what we have here. So I'm testing against Elasticsearch, and I have a parent test here, and that parent test will run through various ways of running those tests. And this is actually doing the work. So what I have here is, at first, I'm trying to remove an inexisting Elasticsearch index, and that will throw me a 404 because, well, it doesn't exist yet. Then I will actually create that index with some settings, it doesn't really matter, and I will store a single document in there. So we have a document with the name, the attribute name and the value Philipp, and we will store that. And then we will just make sure that we have actually stored that document. Like we generate a random ID for that, and then we will make sure that that ID is actually there. And then we just have the asserts to make sure that those are covered. And at the end, we clean up the data and remove everything again so we can start over. So from the testing perspective, this is super simple. This is like the hello world. But to see these different testing strategies, that's more than enough for what we want to run here. So running that with containers, for example, I have picked a very simple example where I'm running that against my actual data store. And the actual data store is a Docker Compose file. I'll show you the Docker Compose file in a moment. But basically what we do here is we pick the default port where it's running the scheme and against which we run this. And then we just try to establish a connection to the local default installation where Elasticsearch would run. We run that, and then we'll run our tests. And at the end, we will just tear everything down and make sure that nothing is left anymore. So if I run that, any guesses what will happen? Let's see. So I run this, and we'll see what will happen. And this might take a couple of seconds. Since we are running Zoom as well, I'm expecting all my tests to be pretty slow. I hope we're not running into any timeouts, but this now is actually what we expected. So here we have a connection refused. Why do we get a connection refused? And this is kind of the biggest downside to this approach already, is why we have this parallel Docker Compose file where we specify, okay, I want to run Elasticsearch in this specific version. And by the way, we could update that to the current version. And let's see if that still works afterwards. we just run this Elasticsearch instance with half a gig of heap, and the entire container gets, sorry, quarter gig heap and half a gig for the entire container. We can just run that. But this already shows you what is the weakness here. Let me bring in this other window here, and let's make this slightly larger. So what we need to do is Docker compose up. We need to run this container, and this kind of shows the downside here already. So you always need to manually make sure that you actually have your container running so you can test against it, because it's not started from within your application. And only once you have made sure that this is actually running, then you can actually run your integration tests against this data store, which is, okay, it's doable. It's all in version control here, but it's still not as much fun as it could be. Normally, this would take around 25 seconds or so until Elasticsearch is up and running. With Zoom running in the background and screen sharing, I'm not sure if it works and if it doesn't run into an out-of-memory exception. Let's give this another shot. Sometimes it's a bit shy on the first run.
No worries, it will work.
Yeah, it normally works eventually, because I have like limited the memory for Docker quite a lot, because this is an old laptop, and with all the stuff running here, it can get tricky, but we'll see. So this looks a bit better, but yeah, it will still take like 20 seconds or so. But time for me to drink my coffee. Then this will be running, and then we can run our test against that.
You can also dance to entertain the audience, you know.
Yeah, it's always tricky, you know. I don't have my full ballroom at hand right now. Unfortunately, dancing is also very limited because it requires such close contact to lots of people. And now, actually, you see we bound the container correctly. So now we should be able to actually run our test against this instance. So if I run this again, this should work now. And obviously, the advantage of this is once you have running the container in the background, the test itself will be pretty fast because you don't have to spin up your Elasticsearch anymore. So this will only take like, without Zoom, it's normally like 3 seconds or so. Right now, it might take like 5 or I don't know. Okay, yeah. So yeah, the test times increased a bit, but it's still pretty fast to run your test against that. Downside is you always have this container running in the background and eating up your memory. So let me remove that right away, because otherwise we'll run into this again. Okay, so this is I call it the good old approach. Like you just install Elasticsearch the classic way in a container, you're running it against a cloud service. The downside is you have this external dependency and you need to make sure it's always running. And if you want to parallelize your test, you will, for example, need to randomize the table names or index names in Elasticsearch so that your tests don't overwrite each other, because otherwise you will just have chaos. So maybe we want to have something that is a bit of a cleaner approach. You could try to run Elasticsearch embedded. And there was or is this project from Allegro, which is like the Amazon of Poland. And they're using Elasticsearch and they provide that embedded Elasticsearch binary. So how that works in general, let me show you what we have here, or let me show you what you need to do. So in the POM, you basically say, okay, this is the dependency. You just add the embedded Elasticsearch dependency. And then in your code, rather than just building this client connection, the connection that we have seen before, where you just connect against, okay, this is where the server should be running. Now you have an embedded Elastic. And here you can just start your Elasticsearch instance from within your code. So let me increase that to 90 seconds. Let's try to run this. So here we're doing pretty much exactly the same thing. What this does is basically it will download the binary in the background and then just fork it out as a process in the background. If you have never downloaded that Elasticsearch version, it will take a little time until you download it, and then you try to run it. Here, this fails pretty quickly. And here you have already another downside. What is the problem here? That with that embedded approach, it needs to support the right version of Elasticsearch that you want to run. And this Allegro embedded Elasticsearch has actually been deprecated by now and never supported 7.0 or higher. So you could only use it for 6.x. And by the way, their official recommendation is to use Testcontainers now. We'll get to Testcontainers in a little while, because they think this is the better approach. And I also think that this is kind of like, with Testcontainers, it's kind of the cleaner approach. You can just use any container and then start testing against that. But you will still start the test container from within your Java code, which is the nice thing here, that you could just start the Elasticsearch instance in your code. You could also start multiple instances if you want to. And at the end, of course, besides closing the client connection, you would also need to stop the Elasticsearch instance again. But this is just like before class and after class, that you start and stop your Elasticsearch instance. This approach, is deprecated now, so don't use it anymore. It's nice because it ties into your IDE. You can easily customize it. You can have a custom lifecycle. You can stop and start Elasticsearch as many times as you want. But you need this custom integration, and since they don't maintain that anymore, well, it's kind of like this one is at its end. If you want to run other data stores embedded, there is, I think this Flapdoodle is a German company. They have like embedded process. This is a Java or the generic way to run or embed binaries in Java to run integration tests against that. And they support MongoDB, Redis, I think Kafka, and a couple of others. So you could just basically fork out a MongoDB process from your Java code and run that. And I've used this like 5 or 6 years ago, and it was a great solution back then. But nowadays, you probably want to use containers and not like download the right binary for your operating system, starting that in the background. It's not as cleanly separated, and it's always kind of like a bit harder to integrate. So while you can do that, probably containers will be the better solution. So let's see what we can do around containers. Coming from the Java world, many people really like the tooling in the Java ecosystem. Like I'm talking about Maven here. And they don't really want to get too much into the container world. If that is a long-term strategy and if you will be able to get around that in the long run, I'm not sure. But what you can do, or you can try that. So for Docker, there is the Docker-Maven-Plugin DMP that can do 2 things for you. The first thing is it can build a Docker file for you from your Java project. So you could just say like, from the Java 8 image, I want to assemble whatever code I have here and run this service. And then you can just build a container to run that. So you could both build a container, but you can also use it to start and stop containers. So what we can then do is from within Maven, we can just point to an image and then start and stop that Docker image in the Maven lifecycle. So what that looks like is, let me show you on the code side. And since this is tightly integrated into Maven, we will mostly look at the POM XML. So what you have here is you have Fabricate and you integrate the Docker-Maven-Plugin. And in here, you basically just reference the location of our Docker images. This here is a neat little trick that you can actually just use the version of Elasticsearch that we have specified for our own integration. So the client that you use, you just specify this variable, and then your client will use the same version as the image that you pull down. So those two will always be in sync. This is another thing with the Docker Compose approach from earlier. I would always need to update the Elasticsearch container version in parallel to my application. Whereas here, this is just using this variable, and it will always be in sync and test against the right version. And then what you can say is, okay, these are the parameters, like start with a quarter gig of heap that container, and map the port 9200 into whatever is happening in that container. And this is the client connection, and then just run that. And at the end, it can also stop the container again. So you have here the goal stop, and we can stop the container. So to give you an idea what that looks like, let me switch over to the right directory. So we have what we run here. This is what we want to run. So we run Maven, then we start the containers that we have defined in the POM XML. Then we run our tests against them, and then we stop the containers again. If you would try to run that from within your IDE directly, it wouldn't run the Docker start by default, and it would not, well, then you wouldn't have the container again, and your test would fail initially. So you will need to make sure that the Docker start happens, either because you change the profile in your IDE, or by running it manually. But yeah. So here you can see this is starting the right container, and it will wait now a bit. And again, it will take like 30 seconds or so until that container is up and running. Then we'll run the integration test against that, and then we need to shut it down. So if you really like XML and you want to define everything from the POM, this is a decent approach. It's not as nicely integrated, in my opinion, as other solutions like test containers, but we'll get to that in a moment. One major downside here is, of course, is that you can only start and stop like once through the lifecycle in Maven, but you couldn't start like at first one Elasticsearch instance and then you run the tests, the next class with 3 Elasticsearch instances, because you don't get into that granularity here. You just have the Maven lifecycle, well, running before the test and running after the test. So you have a bit of a more static setup, I would say. So if everything goes right in the background, Elasticsearch will start up now. And at some point, it will then say like, okay, yes, it has started up. It's running our tests. Once our tests are done, it will then shut down the container. So this, again, should only take like a couple of seconds here, like these all work. Luckily, our asserts work here. And yeah, we create, so we couldn't remove an index that didn't exist. We actually created the right index. We index a document, and then we make sure that that document actually exists, and then we clean everything up, and this works. One of the downsides might be, what happens if I run it like this? Obviously, we won't stop the Docker container again, and then we will need to manually clean this up. So I'll let this run in the background. We'll get back to it in a moment. You could, of course, avoid that with the maven-failsafe-plugin to make sure you run something when something fails or when you clean up. But again, it's another step that you need to add and think about here. So it is nice because you can either use any standard container with the Docker-Maven-Plugin or build your own container to test against. What is less nice is that because of the lifecycle of Maven, you start your containers in the beginning, you stop them at the end, and you cannot change anything in between. So you couldn't run multiple tests against a single or multiple Elasticsearch instances, for example. And it doesn't automatically tie as nicely into the IDE as you might wish. Which leads us to test containers, which are probably the most advanced way to run your integration tests against anything with containers, and also the nicest way to run in your Java code. And while I've been talking, I think, okay, this is almost done. What we will have to do here, by the way, is because I removed the stop Docker, the Docker stop phase, we will need to manually kill and remove that container that we have been running. Because while the test will work, if I would start it again, it would fail because I couldn't start another Elasticsearch instance on the same port. Because if I look at this one here, you can still see this is still running and this is blocking the default ports. So if I would try to run that again, it would fail because the ports are already in use and taken. So what I will have to do is I will need to Docker kill this one here. Then we run the Docker remove on it as well. And then luckily it's gone again. but it required a bit of a manual cleanup step. Okay, so test containers, finally. So test containers has multiple ways or modes to run them. One of them is Testcontainers Generic, which is pretty much like we have a generic container. You just reference the image. I picked Redis 600 here. And then you tell it, well, this will expose a port on, this is the default port number that Redis runs on. So this is where this will end up. And then you can just run against that. You can also run against the Docker Compose file. So what I'm doing now is I will take the Docker Compose file from the very first example that we had, and I will just run that, but run it through test containers. So just to give you a quick idea what the code here looks like. And again, this is just a kind of like config. So we have our Docker Compose file. What is nice now here is I will inject the Elasticsearch version through an environment variable, and the version I actually get from the POM XML. So again, my client version and the Elasticsearch version which I test against are always in sync, and I never have to update the version here explicitly, only in my POM XML. And then from the test containers perspective, you need to reference the Docker Compose file. Then I just defined a wait strategy. So I'm waiting for it to be available to respond with a 200 with a 90-second timeout. And I will just start this container. Once the container has started here, then I will build my client connection again. So here you can see we just built that high-level REST client. And at the end, we will need to close the client connection and then stop that Docker container. And this should just work if I run it from here. So let's run this. And again, it will take a little while to actually start up. While this is starting up, we can use the time to see what is actually happening on the Docker side here. So again, we can just run docker ps. Okay, it's still in the startup process. Okay, you can see the first thing that is running here is this weird process, which is, I'm never sure how to pronounce it. It's Ryuk. I don't know, different people, different opinions. It's written like this. I'll just call it Ryuk, which is probably not correct, but you will know what I mean. We'll get back to that a little later. But now it has started a couple of other containers. So for example, you see we have a Docker Compose container running because we're using Docker Compose. So this is actually, since we're using Docker Compose, this is just used to start this Elasticsearch container. So this is just like, and this was stopped pretty much right away because it was just there to bootstrap the Elasticsearch container from the Docker Compose, basically. Ryuk is there to clean up at the end, but we'll get to that. And then we also have socat running. We'll also get to socat in a moment. And while I have been talking, hopefully the container is coming up now. You can still see, okay, it's starting Elasticsearch with Docker Compose. And once it has brought up the Elasticsearch container, it will run the tests against it and then finish. And yeah.
We need to get you a better laptop.
Yeah, well, this is the 2015 version, and I kept it because of the keyboard, and it still has the HDMI port, like the native one. It's not USB-C, so it was very nice to use because of those. But yeah, it's fine.
Well, I got the new MacBook Pro from 16 inches, and it's actually quite good. So it doesn't have the HDMI, but at least it has an X key, and the keyboard is fine.
Yeah. Yeah, the new ones have the proper keyboard again. And okay, we ran into a timeout here because timeout waiting for that. So then the 90 seconds were not enough for this example. So we could just change this to 120 seconds. You'll have to believe me that this works. I don't want to spend too much time on this one. But yeah.
No worries, guys. I'll vouch for Philipp. I'm pretty sure this works.
Yeah. Thank you. By the way, I will reference the code at the very end so you can just try it out yourself. And without running Zoom, it will start in like 30 seconds or so. I'm mostly blaming Zoom here, by the way. So moving on, we've seen this. What I wanted to mention, so socat is a Mac-specific thing. So only on Mac, you need to expose the socket cat, which basically opens a TCP port that test containers can influence other containers. So you need this extra container running that test containers actually can instrument that on a Mac. The joys of containers not being, or Docker not being exactly the same on all the different operating systems. And then for cleanup, we have Ryuk, or however you probably properly pronounce it, which looks something like this. So this is Japanese manga, and its favorite food is an apple, which is it's holding here. And what it does is it can drop a death note that allows a user to kill somebody simply by knowing their name and face. And while we don't know the face of the Docker container, what Ryuk will do at the end is once everything has run, okay, we're done here now. But even if we don't stop everything correctly, Ryuk is the one thing that will keep running a little longer than everything else, and will keep it running a couple of seconds longer than the actual test, and will check that any resource starting by our test is actually removed. This is kind of this death note. So it knows all the names of the containers or Docker IDs of the containers started from your test, and will then make sure it cleans up and removes everything that is left, even if your cleanup fails in some way. So even if we run into this timeout and we couldn't properly start Elasticsearch correctly, it will still make sure that nothing is left and we don't have to have any lingering Docker containers on our system, which is very nice. So you don't have to worry about that at all anymore. Okay, so it ties nicely into the IDE. You can customize it. You have a custom lifecycle. So we could just start multiple Docker Compose setups without worrying. And we could just start one Elasticsearch instance, and later on we start 3 Elasticsearch instances just to run various tests. And you could just tie that into an add before method or add before class, whatever. Configuration is still slightly hacky because we need to inject the version number through an environment variable and everything. So what would be even nicer? So test containers have custom containers, which just provide like an Elasticsearch test container out of the box. If you search on Maven Central for org test containers, you will see the various test containers that they natively support. And you can just run those and then run everything from within your code. So for Elasticsearch, there is an Elasticsearch container that you can just use for that. Let me show you what that looks like in code. So here, again, we're loading the environment or the Maven variable to get the right version. And then we can, in our code, just say like, okay, based on this image here, and then we just plug in the current version that we're also using for our client. We're trying to start this up, and let me increase that to 120 seconds and try to run it in the background, and hopefully this will then work. So we give it 1/4 of a gig of heap again. We lock the memory so it doesn't swap. We make a temporary file system where it will put its data, and once that one is up and running, then our client will connect to it, and at the very end, we can clean up our containers again. And here I'm also logging like, okay, this is how long it actually took to run this. Again, in the background, we can check out which containers we have running here. So, okay, since it's just starting up, only Ryuk is running. And now you can see, now it didn't start Docker Compose because Docker Compose is not involved here. So it's starting the Elasticsearch container right away. So it can actually run that. And we don't need socat because the socat is only like to get from the Docker Compose to Docker basically on a Mac, that's where you would need socat here. So here, this is trying to start Elasticsearch up, which, well, has been running for 29 seconds now. We could look at the Docker logs for this ID, but I just hope that this will work. So it's still in the starting up process. Once this is done, it will run the tests against it, and then it will shut it down again. Time-wise, we have still 10 minutes left. So if this fails, I would give it another shot, actually, because we have just one more thing that I wanted to cover after that. But yeah, I have pinned the Docker process to one core and given it 1.5 gigs of memory only, so that it doesn't kill the Zoom. But yeah, let's see. This is still running about a minute ago. We could just see what this is up to. This actually looks better. So this is just in the process of coming up. So yes, now it actually came up. It's running its tests, and this will succeed now. So yeah, if you run Zoom as well, be generous with the timeouts. Luckily, you can just define that your own wait startup timeout here. So whatever makes sense for your system, just pick a good one. And you can see here, it's running through the exact same steps as before. So this worked. But this is not a very pretty number in terms of tests. So get a faster machine than me to make this more fun for you. Okay, so if you want to support other languages, test containers are trying not to be just Java specific, like they're coming from the Java ecosystem, but they also support Scala and Go, and a couple of other programming languages are like trying to integrate it as well, because it's just such a great way that from within your code, you start the container for the integration test, and then you can just start it up, tear it down, change the version, do whatever you want. And this is just a very nice way to integrate those. You can also use UI tests. So it does support Selenium and Webdriver. And you can just, for example, say like, if the test fails, store the recording so a human can actually look at it to figure out what UI test failed here. So good IDE support, you can customize it, you can have a custom lifecycle. You might need a custom integration, so with the Elasticsearch test container. But in the end, you could just use a generic container and then define a wait for strategy on the default port, and you could easily do that yourself as well. What happens if your programs are running other containers or in a container? So what I assume here is, for example, we want to build our artifacts in a container, and that, to run the tests, needs to spawn another container. So we run in a Maven container, we want to build our software, and to run the test, it will then need to spawn another container. How do you do that? And this is generally like the wormhole pattern in space, where you expose the Docker socket to that one container, so it can kind of reach out and start another container on the outside. Which, yeah, it's called the wormhole pattern. What you end up doing is, you do a Docker run. I'm running Maven 3 here, so this is the image on which I run. And then I say, okay, I need to include the parent where this is running, because this is where the test is defined. And then this custom test container strategy, this was the last code bit that we ran. And the Maven step that we run is we want to run a test on this. And we need to expose the working directories so that it can actually build the code. And we also need to expose the Docker socket so that from within the Maven 3 container, through test containers, it can start another container, the Elasticsearch container. What will happen here, and why this will take almost forever to run and why I don't show this, is that this would need to download all the M2 dependencies, because we are not writing that into the Maven image. So what you probably want to do is you want to mount your local M2 folder into that Maven 3 container, Otherwise, you would always download all the dependencies. And with Elasticsearch, we have Lucene and Elasticsearch and lots of other dependencies. This would take quite a while. So just to let this run in the background. And the trick here is we need to go one directory up, and then I need to, I think I have that in my, these are not what I want. This looks like what I want. So Docker run, we mount the socket, we mount the M2 folder, and we run this. So this will run Maven 3, build our software in there, from in there start through Testcontainers the tests. So if you wouldn't have added this setting, this would now download jars or the jar dependencies forever. And this will still run for a bit in the background because right now it's just compiling everything. And then it will run the containers. And I'll let this run in the background, and we'll come back to it at the very end to see if it actually succeeded. So to wrap up, I hope we don't have to discuss why you want integration tests, because we've seen a couple of places where without integration tests, stuff was failing miserably. I hope I've shown why mocking is generally fine, but it doesn't cover all the ground, especially around data stores. In-memory data stores, either you don't have one, like for Elasticsearch, or there might be slightly different and then throw you off. Running against the actual data store that you run is kind of annoying because you always need to make sure you have the right version and it's actually running on the system. What is much nicer is you could embed if your system is supported or your data store is supported by embedding. You could run it through Docker build, the Docker-Maven-Plugin, if you want to stick to Maven for everything. But I think the best approach would be Testcontainers, because then you could just instrument everything from within your test code directly, and you have the most flexibility. So if you want to run the code, everything is running in or living in integration test demo on my GitHub account. I will have a QR code for the slides at the very end, so you can just go to the slides and then find the code from there. By the way, be careful with your tests. You don't want to end up like this. So initially, everything was broken, and then your tests take over, and the world is just ending up in flames. So write proper integration tests to avoid that. So here's the QR code. Time-wise, we have 3 minutes left. So we just came to the right point. So it's still trying to start Elasticsearch 7.7. So it compiled everything. It's trying to start up Elasticsearch. Let's give it another couple of seconds if it manages to get this up with Zoom in parallel. Otherwise, I think we're good for questions. And
yeah, I mean, thank you so much, Philip. That was an awesome presentation. You know, Testcontainers is probably one of my favorite leaves these days. It's one of the leaves I add to every project that I'm working on.
We really love Testcontainers as well, because since we don't support embedded Elasticsearch anymore, people were coming to us and said, like, okay, what is the proper approach for integration tests? And we were like, I don't know, we don't really have a great solution for that. But with Testcontainers, we're very happily pointing to that, and it's working really well. And luckily, demo worked. So
so we have a few questions over here for you.
Yes.
So this one's coming from Martin. He's asking, could you mention again what are the pros and cons to not use DataMongo test or the annotation DataMongo test for testing data layers in Spring Boot applications as opposed to using Testcontainers?
Not using, sorry, which annotation?
DataMongo test. From Spring Boot. Are you familiar with that?
No, I'm not. I don't think I'm familiar with that. So
So basically, it's kind of like Spring Boot has these like annotation called @datamongo test. So you can create your own data layer in Mongo for Spring Boot. But I'm guessing what they do is they probably start up an embedded DataMongo on the fly. I'm not completely sure either.
If it takes a bit longer for the first time you run those and you see that it downloads something into a temp folder, that is normally the embedded approach. So every time you switch the version, you would see that it takes quite a bit of time to start, and then you would have a forked out process.
Yeah, so data Mongo test, I'm just checking. It uses the embedded in memory MongoDB process.
Yeah. Yeah.
Then we have here a comment from Miguel Ferredo. He's mentioning the other day we're using Ryuk, and they had an issue. It was not being hosted in any Docker hub because the site was down, and then they had to override Testcontainers to make it work.
Yeah.
Not sure if you experienced that before.
No, I haven't, but I know that like for our integration test service, we just replace them quite frequently whenever something like that happens. So yeah, since it's just on the testing layer, yeah. But probably also, I think Ryuk also has gotten some upgrades. I don't know the specific case, but I guess you just need to figure out why and what happened there.
Sure. Then we have Bruno Batista asking about how to run Docker inside Docker, but I guess that you did explain that.
That's the wormhole pattern.
Yeah.
Which
is quite nice. Yeah. Yeah, I mean, I think we're pretty much out of time. So for people in the audience, if you have any more questions, please feel free to relay them back to Philipp over Twitter. I'm pretty sure that Philipp will be happy to answer them.
This is where you can find me.
Yeah.
By the way, if you're wondering, this is a rot 13 of my last name. This is how you get to this weird thing.
Mm-hmm.
So you rotate the letters of this, and then you get this.
Yeah, that's wonderful.
Happy to answer any questions that you have.
Yeah. Yeah, Philipp, so thank you so much for joining us today.
Thanks for having me.
I think it was an awesome presentation, and we hope we can see each other again pretty soon.
Hopefully in person next time.
Yeah, hopefully in person next time. Okay.
Thanks a lot.
Thank you. Bye-bye.
Bye.